Hopefully you found that the first section of 3.1 went pretty solid for you with all the review of slope and how you graph using XY values. So if that's the way you graph, we're going to show you the other methods that some of you may prefer better in this section as a good review again. And we're also going to talk about some of those properties of linear functions. So let's look. The graphing will not go away. So even though we have a colorful picture here, you should be able to identify every single one of these lines and which line the equation represents it. So in class, if we ask people to match them up, would you say it's the pink, the lime green, the blue, the yellow? So look at them all and see what you've got, and we will go from that as a little discussion piece in class. All right. With that, remember that in standard form, we said ax plus by equals c is that equation that represents standard form. A is the number in front of the x value, b is the number in front of the y value, and they cannot be 0 at the same time, because that would basically wipe out our equation. So one of them could be 0. For example, if a was 0, we'd have a horizontal line. If b was 0, we'd have a vertical line. So things to remember. Now, slope-intercept form of a linear equation, as you know, is y equals mx plus b. We should be really good at all these different forms of our lines, where m represents the slope, b represents the y-intercept. You should also have memorized by now the slope of a horizontal line is always 0, and you should also know that that horizontal line is always the equation y equals b, where b is a number only. Same thing with the vertical line. We have undefined slope there, and our equation is x equals a, where a is our number. Okay? All good stuff that should be reviewed. Slope represents the steepness or the rate of change we've been talking about in our Chapter 2 stuff. The rise is the change in y. The run is the change in x. We've heard that. The slope formula, y2 minus y1, x2 minus x1. We've also said just the change in y over the change in x. You should know that reading left to right, that a positive line slopes up. So you should be able to look at it and say, oh, it has positive slope. Versus if it falls from left to right, you know it has negative slope. Slope is also always represented by a whole number or a reduced fraction, but we never used mixed numbers. So 2.5 would not be a good representation of a slope. 5/2 would be the better choice. So from here, the way to graph a line using slope-intercept form is what we call the quick graph method. Number 1, some of you will remember this. Plot the y-intercept, count up and over the amount of slope, and plot a point at that location. Then draw a line through the points. Again, slope is positive. Your line better be going up from left to right. And if slope is negative, it goes down. So we'll try a couple, and you can try a couple also. But it says graphing using slope-intercept form. So right away, the first thing you need to identify is what is your slope and what is your y-intercept. We'll assume that our graph is labeled by 1s. So in this situation, we have a -3 as our y-intercept. Find that and graph to start with. There is our point, 0, -3. From there, we need to move up 5 to the right 1. So count them. 1, 2, 3, 4, 5. We place, to the right 1. We place our point 5, 1 after the whole slope is done, not in the middle of it. If you wanted to go again, because you have enough graph paper there, you would go 1, 2, 3, 4, 5 over 1, and you'd have a next point. Then get your ruler out and highlight what you wanted. We know all the points, fractions, decimals on that line, so we're going to pull this down, and our line has to go through these points. Make it a little longer than and line it up a little. And so with the edge of your calculator, a ruler, something like that, you should be good and have your line that represents that equation. So that's the method you're going to use. And all of these are in slope-intercept form. So see if any of them would trick you. And you can see them as we go. Y equals -x. That one we might want to talk about. Y equals 6 minus 3x. That one I would say is backwards from what you're used to. Also is this one. We usually say y equals mx plus b. Notice this is y equals b plus mx. This is a fraction, 2/3 x minus 1. Negative 1/4 x plus 8. So we're still graphing our y-intercept first, then our slope. Here's one that has fairly large numbers. You might want to count by 2s or 3s or 5s if you start getting big slope values and y-intercept values. But again, done the same way. Now, here's one. Graph using slope-intercept form. If you're going to graph using slope-intercept form, you're going to have to rewrite this. So if we take our original equation and work on rewriting it, which you've done, remember we want y equals mx plus b. So let's get rid of this 3x by subtracting 3x from both sides. So we will subtract 3x. That'll leave us a negative 3y equals, I'm going to put my x first, negative 3x plus 12. We still would have to divide by that negative 3 because we need y by itself, not negative 3y. And when we do that, we have more reducing to do. So y equals, a negative divided by negative is a positive, and 3 divided by 3 is 1. So you could say 1x if you like, or you could just say x. And then 12 divided by 3 is 4, but a positive divided by negative is a negative. So if you just want to say subtract 4 or plus a negative 4, and that would be the equation then you would graph. Because this was standard form, and we weren't graphing from standard form. We were graphing from slope-intercept. So you have to recognize the form they're giving you and go with it. So here's a couple more there. This one is not even in standard form exactly. It's sort of mixed up. You would have to rewrite it. Look at the one down here in the bottom right corner. This one has distributing going on. You are going to have to distribute, move things around, and get it in y equals mx plus b format. If those are some of them you want to talk about in class when we can, make sure you note that in your notes. Now I'm looking at two equations, and we've done this before, geometry especially. Look at the equation in red, y equals 3x plus 4, then the equation in blue, y equals 3x. What are you expecting when we graph these two lines? Do you notice anything about them? So let's just go with our example that we did. I've got the blue line we're going to graph first, so I look at that and say, oh, that is really a plus 0, even though there is no number there. It's the only number we can't write. So I know my y-intercept is 0, so I place my point at 0. And then I know my slope is 3 or 3 over 1 if I'm looking for my rise over run. So up 3 to the right 1, up 3 to the right 1. I could again draw my lines and try to get it as close as possible. Going a little, extended a little past that first one. Are they all on? We can move that top one over a little. Okay? So there's our first line. Now if we do the same thing in red, what are you expecting to see is what the question is alluding to. So we would first graph the 4 for the y-intercept, up 1, 2, 3, 4 on the y-axis. Let's make it red though, since it matches the red line. There's the 4, and then from there the slope should be up 3 over 1. So if we go up 3 and over 1, up 3 and over 1, we're going to be right at the top there. And again, draw your line, compare what you have. Go a little farther if you can. Ours is a little tougher in this case, so we'll come down a little farther. Try to be right on those points. And what are we seeing? Those two lines appear to be parallel. You learned in geometry that parallel lines must have the same slope. I do believe these do, and that's just another characteristic you should be looking for. Here, identify your y-intercept, your slopes, and notice, before you even start graphing, you could have an idea of what you're supposed to get. So you're not in the dark. Try to analyze what they've given you. Then here's one, again, in standard form. And the second one is also in standard form, but it has a 1/2, so 1/2 y minus x. You'd have a little rewriting you'd have to do before you could see what's going to go on in this one. And so, with that, we should be ready to graph some lines that either come from standard form or slope intercept form. So good luck, and bring any questions you have about